This video was brought to you by Squarespace. Biomimetics, Nature's Design. In the 30th of June of 1885, somewhere in Austria, a baby was born. He didn't stay like that for a long time and eventually became a boy, called Victor. Victor liked to spend his time in the middle of the forest, what makes sense since his father was a forest superintendent. He liked to touch the trees, feel the wind on his face, and most of all, observe the water. Water makes up 70% of the world's surface and 70% of the human's body. But Victor didn't know that at the time. He just liked to look at it and admire how water flows through the rocks, interacting with the fish and slowly molding the landscape around it. Victor quickly understood the power within water, so he kept observing and observing and observing. The years passed by and Victor the boy became Victor Schauberger, the waterbender.
Literally. Victor Schauberger developed many devices that bended water, either to produce energy or propulsion. And even if the final goal of these devices was different, the root principle was the same. The natural flow of water is not a straight line, but instead a spiral vortex. Of course, this principle is absurd. It doesn't take much to look at a river and realize that water is not flowing in a spiral. Or is it?
Water is a liquid, what means that it flows, as liquids do. And as far as flow goes, there are two main types. Laminar flow, that consists of smooth parallel lines that are beautiful to see and as rare in nature as a yeti playing a banjo. And turbulent flow, a chaotic disarray of water molecules that flow in a random way and it's everywhere, including rivers. One particular characteristic of turbulent flow is the appearance of small spots of rotating liquid that form localized vortices, and that is called vorticity. You may not be able to see them since water is transparent, but they are there.
We have established that vortices are common in natural flow, but only at the micro level. What about flow that completely takes the shape of a spiral?
If you ever wash the dishes, you know that when you empty out your sink, there's a natural tendency for a vortex to appear. That happens because the drain acts as a constriction that, due to the conservation of momentum, accelerates the already present spinning motion. This progressively increases the rotation of water, what creates a macro vortex flow.
A vortex flow is a mesmerizing thing to watch, but it's also a very useful one, and that utility comes from the simple fact that water and air always move together. So, here I have two bottles and a connector that I 3D printed using the Not Jordan. In the bottom one I have water, and if I want to transfer this water to the other bottle, well, I just need to flip them, and gravity will take care of the rest. Very slowly. Because of the constriction, the air will cut the flow of water. But there's another way to do it. If I impinge a little bit of circular motion in the water, a vortex will generate, which will basically speed up the process. Let's try it.
The vortex pushes the water to the outmost perimeters of the bottle through the magic of the centrifugal force. This creates a center pathway for the air to flow without interfering with the water. Adding some particles to the flow allows us to better understand the double flow and realize that we actually have two concurrent vortices, one made of water and the other made of air, both interacting harmoniously without disrupting the other.
Biomimetics describes the intuitive tendency that humans have to solve problems using solutions that already exist in nature. We wanted to fly, so we looked at birds, and we copied their wings. There are many examples of humans copying nature, but my favorite one involves spirals, water, and mathematics.
In the year 1202, an Italian mathematician published a book called Liber Abaci, where it described the ideal growth for a colony of rabbits. The mathematician was Fibonacci, and the growth of rabbits was modeled using the Fibonacci sequence. The Fibonacci sequence is a group of numbers where each number equals the sum of the two numbers before it. If you take these numbers and you represent them graphically using squares, you get a spiral.
Now, you're probably thinking, in Texas, that's just a made-up sequence that creates a made-up spiral. What does that have to do with nature? And to that I say, sunflowers.
Sunflowers had a serious problem to solve. They have a limited amount of space to grow seeds, and they wanted to grow as many as they can to improve the chances of sunflower babies. If you approach this problem with a linear perspective, you will waste a lot of space. The ideal solution is to rotate each seed as they grow, but by how much? At methisfun.com you can try different rotation values and see what results you can get. Maybe half a rotation? Maybe 3.14 rotations, which is pi. Or maybe 1.618 rotations.
Now that looks good. Or better yet, that looks golden. As you can imagine, I didn't come up with this number randomly. In fact, I didn't come up with this number at all.
This number is the golden ratio, and is the ratio that is followed by sunflowers and also by the Fibonacci sequence. And that is the reason why the Fibonacci spiral is actually called the golden spiral.
You can find many examples of the golden spiral in nature, and the reason why that happens is a mystery to me. But here's an idea. What if I took the golden spiral, projected it into 3D space, and then 3D printed it? I'll be right back.
Sponsor time!
Hello, hello, hello! My name is Intexa, and my goal in life is to conquer the world! So far I conquered my house. I conquered my room, the living room, the bathroom, and the kitchen. Also, I have my eyes put on my neighbor's house. Of course that if I want to conquer the entire world, I need some help. So I created a website called InTexaConquersTheWorld.com, where I'm recruiting people to help me conquer the entire globe. To create the website, I used a very useful website building platform called Squarespace, where you can create any kind of website very easily. They have great tools that allow me to do the email campaigns, share ideas in the social media, and most important of all, receive donations. Sorry about that. If you also need the website, you can go to squarespace.com for a free trial. And when you're ready to launch, you can go to www.squarespace.com/intexa to save 10% of your first purchase of a website or domain. Come on, do it! The world won't conquer itself! Back to the video.
Now this is a beautiful shape. It kinda looks like a lily flower. Or at least its inventor thought so when he came up with his name. This is the Lil Impeller, and was invented by J. Arman in 1996. Nowadays it's used as a high-efficiency water mixer for giant tanks of water, but it was meant to be used as an impeller. An impeller, just like a propeller, is an actual element that produces thrust. But the big difference is that a propeller pushes the water, while an impeller, well, impels it. To better illustrate this concept and kill my curiosity, let's build a water tank, attach this little impeller to a motor, and do some tests. Okay guys, we're ready to do some tests. I'll put now the Lily Impeller into the motor shaft.
Let's fill it up with water!
Doesn't seem to be leaking all that much. I'll connect the power supply now. Let's test it. Come on, that's cool. Now I'll put some of those confetti thingies so we can visualize the flow. Three, two, one.
As you can see, the Lil Impeller pushes the water downward, what creates a low pressure at the center. At the same time, its rotation impinges a circular motion to the water. These two things combined create a steady vortex that is able to mix the water in the entire tank.
So I'm gonna switch the cables so the turbine spins the other way around to see if I see any changes, or I don't know. I just want to try it. Okay. Okay, let's try it this way. In 3, 2, 1.
Even when rotating it in the opposite direction, the water is still displaced outward, but this time in a positive angle. The result is mostly the same because we still get a recirculating flow that starts at the bottom, is pushed to the top, and because of the low pressure at the center, ends up flowing into the impeller again, which means that in the end, the vortex is still generated.
This fascinated me, but at the same time it kinda looked familiar, because the behavior of flow was in almost everything identical to one of the most used pumps in the world, the centrifugal pump.
To test my hypothesis, I 3D printed a simple centrifugal pump and tested it on the tank. My suspicion was confirmed. They basically behave in the exact same way as a pump.
The big difference here is the reversibility, because the Lil Impeller can also be used as a turbine. Instead of being the impeller moving the fluid, what about the fluid powering the impeller?
Here you can see a small spiral turbine with a similar geometry to the Lil Impeller, being driven by smoke. As the smoke passes through the turbine, it changes direction gradually and loses most of its kinetic energy, which means the kinetic energy is going to the turbine.
At this point, the idea of making a wind turbine using this geometry became irresistible to me, so I 3D printed one. The turbine was ready, and for once, I wanted to test it with actual wind, instead of using my air compressor.
My first test was on the beach, because even I need some vitamin D from time to time. It was actually windy, but the turbine didn't perform well. Getting to 1 volt was a dream out of reach. Thinking I needed more wind, I went to where the wind is supposed to be.
Today we are here to return this baby turbine to its natural habitat, with its family where it belongs, with its big sisters. So, I shit you not, I drove 20 miles from my house because I'm thinking, in Texas, you record too much inside the house. What about instead of using a hair compressor, you use actual wind to test the turbine, right? So I think, where can I find wind? Well, at a wind farm. In a wind farm I can certainly find wind. Well, I was wrong. Not the slightest breeze. I'm just unlucky. Jesus.
I had no wind to test the turbine, so I did what I normally do. I used my air compressor, and that was when I realized my mistake. The reason I could barely get to 1 volt was because I was using a high-speed motor as a generator. This type of motor gets to almost 20,000 RPM using just 3 volts, which also means that to use it as a generator and get 3 volts, it needs to spin at almost 20,000 RPM. And even with my compressor, I was only getting an output speed of about 2300 RPM.
Using that motor was a bad idea, but most DC motors behave like this. So if I wanted to use a DC motor as a generator, I needed to find a way to increase the output speed. So I used gears.
To solve my problem, I bought some DC motors with planetary gearboxes with ratios of 1 to 30. That means 30 times more speed. Even turning them slowly was getting me over 3 volts. It seemed like I found my solution, but I didn't.
You see, I forgot the law of equivalent exchange. Yeah, I got more speed, but I also got a lot more resistance.
It was really hard to turn the axis of the geared motors. There was no way the turbine was going to produce that much torque.
I was running out of ideas. The desperation of a failed project was beginning to take over.
You're a loser in Texas.
You again?
If you can't finish the project, nobody's going to subscribe to your crappy channel. I bet you won't even find a good generator, and you know what that means? no likes, no shares, no nice comments telling you the project was cool. This is the Stirling Engine project all over again.
Hey, I was able to make the Stirling Engine work, okay? The Stirling Engine! That's it! Thank you, evil voice that represents my fears and anxieties!
Wait, what? In my last video I 3D printed a Stirling engine, but I also have a metal one with a generator. Stirling engines are not that fast and don't produce a lot of torque, so I stole the motor on the engine and I copied the pulley system. I 3D printed a pulley in resin and also a support for the motor. I assembled everything and gave it a test.
Okay, so I'm gonna do a little test with the air gun to see how many volts I can get with the new system of pulleys and the new motor. Okay. In 3, 2, 1. Whoa!
That was a nice improvement. I got almost 15 volts. And that was more than enough to power a small LED light I had laying around. But to be honest, LED lights don't take a lot of current. And as one of you guys told me on Instagram, it's not about the voltage, it's all about the power.
So, one of you guys suggested that I put some load on the generator so I can know for sure if I'm getting a decent amount of power. So what I did was connect this LED light bulb and a 330 ohms resistor. I'm going to test it, see the voltage drop and try and calculate the power. Yep. Let's see.
With a 33 ohms resistor and a voltage drop of about 9 volts, we get a flowing current of 30 milliamperes and an output power of 0.25 watts.
A quarter of a watt? Are you kidding me? Enough of this. If the mountain won't go to Mohammed, then Mohammed must go to the mountain. Wind is just air moving relatively to stuff, right? If the air won't move, it's time to move the stuff.
So I took my little turbine made of fragile PLA on a 75 km/h trip. 75 km/h wind is what you call a gale in wind terminology, and it looks like this. You might not get it because of the shutter speed of the camera, but the turbine is spinning insanely fast, and of course that in these circumstances, the outcome could only be one. Yeah, the turbine exploded, and all my work ended up on the trash bin. I could right away print another one, but I took this time to think and meditate, and that's when it came to me.
Of course, from the start I was taking the direct way, the easy way, when I should be taking a more step-by-step approach.
The answer was in front of me the entire time. Stepper motors. They are low-speed, high-power motors, mostly used in 3D printers to control the position of the axis.
This reignited my will to make a good wind turbine. I was anxious to test my hypothesis, so as usual I sacrificed my first 3D printer.
After stealing a stepper motor from Lalinea, I measured the output voltage and current, and I was getting pretty decent results just by turning the axis with my hand. But before I could use it, I needed to fix the current coming out. This type of motor is a common NEMA 17 motor, and it has 4 wires coming out. Each pair of wires outputs a beautiful sinusoidal wave that is completely useless to me. What I need is to turn those waves into a flat line, and to do that I used a full bridge rectifier. I actually used 2, one for each pair of wires, and I linked them in parallel to get more current. After using my crappy soldering skills to unite all the components, I gave it another hand test, and things were looking pretty promising.
The generator was looking good, but I had no turbine. Since I had to print a new one, I decided to go bigger, so I maxed out my printer's volume and printed a monster turbine with 220mm in diameter.
If you're wondering why the turbine has the color scheme of a 90s tracksuit, well, it wasn't by choice. I ran out of filament 2 times during the print. Being left with only green PLA in the end, I had to print a Colossus support for the turbine in the most common color in nature. When designing the turbine support, I created 2 motor mounts, one for the direct drive and another to drive the motor with gears, just in case I needed to step up the torque a little bit. I 3D printed 2 beautiful red gears in resin with a ratio of 2:1. After that, I put the whole thing together.
When I woke up early in
in the driving rain. HansJohn's out hitting on the liquid gain. He want to late about 10:30 when he let loose for the cat trick. Then it was Sunday.
With the new turbine ready, it was time to run some tests.
I used my compressor to test the turbine using the direct drive and the geared one. I used a load of 57 ohms, and the option that resulted in the higher power output was the direct drive one, with 1.75 watts. It's not an enormous amount of power, but after coupling a power converter to the system that stepped down the voltage to 5 volts and increased the current, I could now charge my headphones, my phone, and a small spark generator.
I'm not gonna lie, I was pretty proud of how the turbine turned out. So once more I decided to take it on a ride, but this time slower.
I placed the turbine on top of my minivan and I used the roof as a way to fix it in place. I know it's not a great idea, but it worked. As I started moving, the turbine started to rotate. Even with speeds as low as 30 km/h, the turbine would many times accelerate in an explosive way, spinning so fast that the noise became scary. 30 km/h is a good test speed because it's not at all uncommon in nature. At this speed, the turbine could easily charge my sister's phone and light up the red light at the same time. I actually found out that for low loads and wind speeds of about 30 km/h, the turbine is able to output as much as 8 watts.
If I use it to charge batteries using natural wind, I might get a decent amount of energy out of it. But for now I need to wait for natural wind. If you're wondering why I started the video talking about the power of water, and I ended up building a wind turbine, well, let's just say that I have a plan to use this turbine with another one to create an awesome hydraulic generator. But for now I need more time.
I know not everyone has a 3D printer at home to replicate this project, and that's the reason why in my last video I promised to give away a 3D printer to the comment with more likes baptizing my hot air engine car. The winner was Angus from Maker's Muse, that gave the name of DP Bird to the car. Congratulations Angus, you just won yourself a 3D printer. I'm just kidding. The last thing that Angus needs is another 3D printer. The actual winner was a subscriber from Brazil, named Lucas, and he baptized the car The Bull. He actually sent me a picture where he's standing next to the printer and thinking, Inetska? I don't know who that is, but I'm really happy you received the printer. If you also want to win a 3D printer, all you need to do is subscribe to the channel, leave a like on this video, and post a comment suggesting a theme for a future video. The most liked comment will receive a 3D printer and I will make a video about that subject. Well, this is everything for today. I hope you enjoyed the video and remember, tomatoes are disgusting. See ya!